Hello there and welcome to Lower 6 Maths A-Level. This is the Applied Practice Paper I. Here we're working on question 2, a statistical diagrams question. So, children from school A and B took part in a fun run for charity. The times to the nearest minute taken by the children from school A are summarised below. Part AI asks for us to write down the time by which 75% of the children in school A had completed the run. So the first person completed the run in 20 minutes, the 25th person completed it in 25 minutes, half of the students completed it within 30 minutes, 3/4 of the children completed it within, that's going to be 32, 34, 36, 37 minutes. So part AI, the answer here is 37 minutes. Part 2 here is state the name given to this value. This is the upper quartile. It could be known as Q3 or UQ. Best to give a few different answers there if you know all or a couple of them. Explain what the two crosses represent on the box plot above. Interpret these in context. These are outliers. So they're not included in the main body of data because they're so, effectively in this question here, they're so slow that they are outside the normal range of students for this school. So we've got two students that are outside the normal range of running times. Okay, so in terms of interpret these in context, these runners are outside the normal range of students times at the school. They were a lot slower. Okay, moving on to part C now. So for school B, the least time taken was 25 minutes, the longest time was 55 minutes. The three quartiles were 30, 37 and 50. Use Q3 plus 1.5 lots of Q3 minus Q1 to determine if there were any outliers. Give a reason for your answer. So in this part here, the lowest value was 25, the quickest time. The highest value was 55. Q1 was 30. Q2, or the median, was 37. And Q3 was 50. So let's apply this formula here to the values that we've been given here. So Q3, that's 50 plus 1.5 times by Q3, that's 50, take away 30, so that's effectively 1.5 times the interquartile range. And what we get for this is 20, that times by 1.5 you get 30, add the 50 and you get 80. Now the highest student was 55, so in this case here there are no outliers because 80 is bigger than 55. Part D, draw a horizontal box plot to represent data from school B so the distribution in times can be taken for the fun run by school B and easily compared to school A. What I think I'll do is I'll plot my diagram just below school A's diagram. So the lowest time was 25, so I'll plot a marker here at 25. The highest person was 55. Q1 was at 30. Q2 was at 37. Q3 was at 50. And then we'll just join up the box like so. Okay, that's part D done. Compare and contrast the two distributions in the context. So when you're comparing distributions here, you need to make sure that you're comparing the average and comparing the spread of data. So for average, we're going to say the average time for school A was faster than school B. And the reason this is because schools A's median time was 30, whereas the median time for school B was 37. 30 to 37. And the school B had more varied finishing times than school A because it had a larger interquartile range. Okay, we don't compare the range with box plots because that will be skewed towards extreme values. The interquartile range here is a measure of spread of the most average 50% students. So this compares 30 to 50, that's 20, to a interquartile range for school A, 25 and 37, so that would be 25, 37, so that would be 12. Okay, so that's a perfect answer to part E here. Okay, great, that's 13 marks for that question.